Evaluate h of t equals the absolute value of t plus 2, close the absolute value, plus 3. Find h of 6. All right, well, h of 6 means we're going to replace every t in here with 6. So that's going to equal the absolute value of 6 plus 2, close the absolute value, plus 3. And then it's just PEMDAS stuff. Do stuff inside the absolute value. So 6 plus 2 is 8. So you got the absolute value of 8. The absolute value of 8 stays 8. And 8 plus 3 is 11. So we would say that h of 6 equals 11. Easy peasy. Evaluate f of x equals x squared minus 3x. And my job is to find when f of negative 8 is my guy. So whenever you're asked to find f of stuff, you replace every x in the function with that stuff. So this is going to be f of negative 8 equals parentheses. Whenever you substitute stuff in, always have the parentheses. So negative 8 squared minus 3 times negative 8. The reason why the parentheses is so important is because when you square a parentheses, no matter what, it's going to be positive. So that guy becomes 64 and not negative 64. While I'm at it, negative 3 times negative 8 is positive 24. And 64 plus 24 is 88. So we could say that f of negative 8 is 88. That's the number that the DeLorean goes back in time and Back to the Future. It's a speed. Remember that movie? Like and subscribe. Evaluate p of t equals 4t minus 5. Find p of t minus 2. Ooh, this is very calculus-y. Like this is almost a pre-calculus kind of problem. Well, what do I do? All right, well, if I'm being asked to find p of t minus 2, let's use these colors, that just means I'm going to replace every t in here with t minus 2. So let's just kind of write it out as a shell. 4 times parentheses, stuff, minus 5. The t becomes t minus 2, like that. And now it's just a distributive property combined like terms type problem. 4t is 4t. 4 times negative 2 is negative 8, and then you have minus 5 lingering out there. Combine like terms, that's going to equal 4t minus 13. So p of t minus 2 is 4t minus 13. Evaluate p of a equals negative 4 to the 3a, and my job is to find p of negative 1. All right. Well, let's replace every a with negative 1, see what happens. P of negative 1 is going to equal negative 4 to the 3 times negative 1 power. Okay? 3 times negative 1 is negative 3. Now, what I can do is leave that negative upstairs technically, put a 1 up there, and bring that 4 to the negative third down and make it 4 to the positive third. That negative can come out front. That 1 can stay there. 4 times 4 times 4 is 64. So I get negative 1 over 64. And p of negative 1 equals just that. And that's how it's done. Evaluate g of n equals n cubed minus 5n squared, and my job is to find g of negative 4n. So what I'm going to do is I'm going to rewrite g of n, but replace every n with parentheses negative 4n and go from there. So g of negative 4n is going to equal parentheses cubed minus 5 parentheses squared. And again, I'm going to replace every parentheses with negative 4n, negative 4n. All right? PEMDAS says negative 4 times negative 4 times negative 4 is going to be negative 64, and n times n is n cubed, minus 5. Negative 4 times negative 4 is positive 16, and n times n is n squared, like that. So that parentheses isn't really necessary, so negative 64 n cubed. 5 times 16 is 80, so minus 80n squared. So g of negative 4n is going to equal negative 64n cubed minus 80n squared. G of n equals n squared plus 4 plus 2n, and h of n equals negative 3n plus 2. Find g times h of 1. All right, so this is what we need to do. We need to find g of 1, we need to find h of 1, and then we're going to multiply them together. Now, those of you who are working ahead, that is not a composite. That is a multiplication symbol. So we need to find each one of these and then multiply these guys together. All right, so g of 1 means we replace every n in g with 1. So 1 squared plus 4 plus 2 times 1 is going to be 1 plus 4. 2 times 1 is 2. 1 plus 4 is 5. 5 plus 2 is 7. G of 1 equals 7. H of 1 is going to be negative 3 times 1 plus 2. Negative 3 plus 2 equals negative 1. So h of 1 is negative 1. So g times h of 1 is going to be 7 times negative 1, which equals negative 7. Not too bad. H of x equals 3x plus 3. G of x equals negative 4x plus 1. Find h plus g of 10. What that means is you're going to find out what h of 10 is. You're also going to find out what g of 10 is, and then you're going to add those suckers together. So h of 10 is going to be you replacing every x with 10 in h. So 3 times parentheses 10 plus 3, according to PEMDAS, is 30 plus 3, 33. Scottie Pippen. Those of you who are basketball fans from the 90s. Also, we have g of 10 over here, and that's going to be negative 4 times 10 plus 1, which is going to be negative 40 plus 1, which is going to be negative 39. So g of 10 is negative 39. So h plus g of 10 means we're going to add, let's write it out. We're going to add 33 plus negative 39. In other words, 33 minus 39, and that'll get us negative 6. Fun. G of n equals 3n plus 2. F of n equals 2n squared plus 5. Find g of f of 2. This is where things get real, okay? So g of f of 2, let me get my colors out, says I want to find, since I give you the value, I want to find f of 2. That'll give me a number. Once I have that number, say it's 1,000, then I can find out what g of 1,000 is. First things first, I have to find out f of 2. So f of 2 means I'm going to rewrite f of n and replace every n with 2. So 2 times 2 squared plus 5, which is 2 times PEMDAS says 4 plus 5. 2 times 4 is 8. 8 plus 5 is 13. So f of 2 is 13. What does that mean? Well, that means if f of 2 is 13, now my job is to find g of 13. So you're going to write out g, and you're going to replace every n in g with 13. So 3 parentheses 13 plus 2. That's 39 plus 2, which is 41. So when all is said and done, g of f of 2 ended up being the number 41. Fun fact, my age. I know. I appear much younger by my voice. Thanks for watching. Like and subscribe. F of n equals 2n. G of n equals negative n minus 4. Find f of g of n. Now, I hate the way that they write out these composites, so I'm going to write them out the way God intended. That is f of g of n. Okay? Now, unlike a problem that I did in the last video, if you watch these all in order, I don't have a value for n. So this is what I need to do. I need to write out all of f, which is not much. I'm going to replace every n of f with a parentheses, but inside the parentheses, I'm going to write out what g of n is. See, whenever you find f of stuff, you write out f replace every n with that stuff. That stuff happens to be a whole function. So in this case, we're finding f of g of n, which is 2 times negative 2 minus 4. Now it's just distributive property, right? You get negative 2n minus 8. There's nothing I can do after that. So at the end of the day, f of g of n just ended up being negative 2n minus 8. Not the craziest thing ever. Are the functions inverses? Well, we have two functions, and this is how you find out if a function is an inverse. If g of f of x is the same as f of g of x, and they both happen to equal x. So let's do g of f of x first. G of f of x. You start out with g, right? And you replace every x with f of x. So instead of x here, you're going to plug in 1/2 x plus 3/2, right? Do a little bit of math. It's not pleasant. We got some decimals and not decimals, but fractions. So you become 4 minus 3/4 x minus 9/4. Well, I guess the good news is we could stop right now and say no. Because there's no matter what we're going to do, no matter what we do here, we are absolutely not going to get x. So whether I did it the other way around to double check, I'm done. You're not going to become x. You're not going to clean out and make some lovely x value all of a sudden. That's it. We're done. Are these functions inverses? No. Are the functions inverses? You find out if a function is an inverse by taking f of g of n in this case, see if it equals g of f of n, and they both have to equal n. So let's pick out f first. Let's do f of g of n first. So f of g of n is going to be me taking f of n and replacing every n with a big parentheses, like so, making sure I don't make any mistakes. G of n is 4 plus the cubed root of 4n all over 2. Oh my gosh. All right, so 2 times 4 plus the cubed root of 4n over 2. And let's do this. Let's put this over 2, 4 over 2 to the third power. When I subtract 4 over 2 minus 4 over 2, these guys will cancel out. So after these guys cancel each other out, that leaves you with 2 times the cube root of 4n over 2 cubed. Now you cube the top, and that leaves you with just 4n. You cubed the bottom, and 2 cubed is 8. 2 times 4 is 8. 8n over 8 is going to be n. So, part number 1 here worked out. Let's make sure part number 2 here works out. So let's start out with g, which is 4 plus the cubed root of 4 times big parentheses. In those parentheses, I'm going to have 2 times the quantity 2 minus 3 cubed, all over 2. 4 plus the cubed root. 4 times 2 is 8. So I have 8 times the quantity n minus 2 cubed all over 2. 4 is still there. The cube root of 8 is 2. The cube root of something cubed is that something. All over 2. Distribute the 2. That leaves you with 4 plus 2n minus 4 over 2. The 4's cancel, which means the 2's cancel, which means you get n. So, are these functions inverses? Yay. Yes. Find the inverses of h of x equals the cube root of x minus 3. What I like to do first is I'm going to replace h of x with y. Okay? That's what I'm going to do first. I don't like dealing with h of x when I do inverses. Step number 1 when finding your inverses, you're going to swap the x and the y. So x now equals the cube root of y minus 3. Now you're going to solve for the new y. So let's add 3. Let's add 3. X plus 3 equals the cube root of y. Let's cube both sides, like that. That cancels each other out. And so you have x plus 3 cubed equals y. Now that y is all by itself, right? And maybe it'll be nicer if I just rewrite it that way. Y equals x plus 3 cubed. Now that that's all by itself, we can call this the h inverse of x equals x plus 3 to the third power. And that's it. Find the inverse of g of x equals 1 over x minus 2. First things first, I don't like g of x, let's call it y. Y equals 1 over x minus 2. Now the first major step in finding the inverse is swap the x and the y. So x equals 1 over y minus 2. Now we're going to solve for the new y. Add 2 to both sides, add 2 to both sides, cross you out, x plus 2 does not combine. Now, common sense would tell us, and we're allowed to do this, that if 1 over y equals x over 2, what we could do is just do a little flipperooski. 1 over x plus 2 equals y over 1. You're allowed to do that. Now, y is all by itself. Looks like that. And we're going to rewrite y as g inverse of x. So g inverse of x equals 1 over x plus 2. Yay. Find the inverse of g of x equals 7x plus 18 all over 2. Well, I don't like g of x, so let's call it y. Y equals 7x plus 18 all over 2. The first thing in finding an inverse is you swap the x and the y. So x equals 7y plus 18 over 2. Now we solve for the new y. Step number 1, multiply both sides by 2, like that. That happens. So you now have 2x equals 7y plus 18. Let's subtract 18 from both sides. So 2x equals 2x plus minus, oh my goodness gracious me, 2x minus 18 equals 7y. Divide both sides by 7, and let's write out over here that y will equal 2x minus 18 all over 7. I don't like that it's y, it should be g inverse, so g inverse of x is going to equal 2x minus 18 all over 7. And that's that. Find the inverse of h of x equals 2x cubed plus 3. All right, I don't like how that's h of x, so let's call it y equals 2x cubed plus 3. First things first in finding your inverse is swapping the x and the y. So x equals 2y cubed plus 3. Now let's solve for the new y. Subtract 3, cross you out. X minus 3 equals 2y cubed. In order to get y cubed all by itself, we're going to divide everything by 2, like so. So I have x minus 3 equals, over 2, equals y cubed. In order to get rid of a cube, you cube root both sides. So cube root both sides, that happens. And y is now alone, and that's going to be the big cube root of x minus 3 all over 2. Since y is not the original problem, I'm going to go back and call this h inverse of x equals the cube root of x minus 3 all over 2. And that is how you do that. Find the inverse and graph both. Let's first graph this f of x right now before I even consider the inverse. Now, let's plug in a few points. I'm not sure how many points we can plug in. Let's plug in -2, -1, 0, 1, and 2, and see what we get after we plug those in, and that'll help us figure out what kind of function we have. If I plug in -2, that's going to be -2 times -2 cubed. So let me do that work over here. Big number plus 1. So that's going to be 8. That's going to be 17. So we can't even graph that. Let's plug in -1. -2 times -1 cubed plus 1 is going to be -2 times -2, or -2 times -1 rather, which is +2, and 2 plus 1 is 3, so that's manageable. If I plug in 0, I get 1. If I plug in 1, I get -2 times 1 cubed, so -2 plus 1 is -1. And if I plug in 2, I get -2 times 2 cubed. Again, really big number. It's just not going to work out, not even worth it. So the 3 points that I can do is -1, 3, 0, 1, and 1, -1. And since this is a cubic, it's going to look something like this. Now, I'm awful at drawing these, so bear with me. Bear with me, bear with me, bear with me, bear with me, bear with me. All right, so that's what the blue function is going to look like. All right, now I'm going to find the inverse, and I'm going to show you a little trick how to graph its inverse. Okay, so here's the inverse. First things first, I'll call you y. All right, because I don't like f of x. It's just too sloppy for me. First things first is swap the x and the y, so -2y cubed plus 1. Subtract 1, cross you out. X minus 1 equals -2y cubed. Divide everything by -2, gross, cross you out. That leaves me with x minus 1 over -2 equals y cubed. In order to get rid of that cubed, we're going to cube root both sides, like that. Okay, you cancel out. Y will equal the cube root of x minus 1 over -2. So f inverse of x is going to be the cube root of x minus 1 over -2. Now, this is the trick to graphing the inverse if you already have the graph of the original function. We were able to graph 3 points, -1, 3, 0, 1, and 1, -1. We were able to graph those 3 points. When you want to graph the inverse, the trick is flip-flop. So 3, -1, 1, 0, and -1, 1. Why? Well, because the first step that you do is you swap the x and the y. So why would that change here? So 3 points that I can graph would be 3, -1, 1, 0, and -1, 1. So graphing this is going to be very, very, very similar, which means it's going to not look good. But there you have it. And if you're curious as to what the graph of a function and its inverse looks like, what you do is you draw a perfect diagonal line, right? This is the line y equals x. You draw a perfect diagonal line, and your function and your inverse are mirror images over that line. So that's why if you kind of tilt your head sideways, you could see like a butterfly looking thing. Pretty neat stuff. Pretty neat stuff.